Last class, we did everything that we needed to do to set ourselves up to be able to graph. So I feel like today should be kind of like a nice, easy day before a break because we're just graphing. The graph of a quadratic, it has a name and it starts with a P. I know you've heard it before. Can anybody remember it? Say it again. Parabola, very good. And it spells like parabola. Parabola. So the shape of a quadratic graph, it looks like a what letter? U. It looks like the letter U. And that shape for a graph is called a parabola. Again, it spells like parabola. So all of our graphs today need to look like that. This we learned last class that we have vertex form. This is what it looks like. And what is the vertex? HK, very good. HK, so HK. Let me see if I can make this a little bigger because I'm having a hard time squeezing all the words in there. There. All right, this is all review, so y'all should be real good at this. The y-intercept is when what is equal to 0? X. When x is equal to 0, and it's where the graph crosses the y-axis. Okay, I'm going to pause for a second. Y'all dig out your notes from last class. I think you might need them. The reason that we take notes is for you to use them as we're learning new stuff, to use them as you're practicing. So anytime we're taking notes, unless it's a brand new unrelated unit, you should have your notes out from what we did before because we build on it. So the vertex does what? Cuts the graph in half. And it represents the what or what? It represents the maximum or minimum point. So remember that the maximum point is going to happen when you're facing down and you have a maximum. The minimum happens when you're facing up and you have a minimum. The axis of symmetry always goes through vertex. And I don't think I mentioned this with your class, but it's always x is equal to, it's the x value of the vertex. So you could say x is equal to h. The graph will open up when a is positive and down when a is negative. And so A, remember from the equation, it's what's right in front of the parentheses. That's how you know if something opens up or it opens down. So when it's positive and it opens up, that means that it's a smiley face. And when it's negative and it opens down, then that means that it's a frowny face. So you're happy when you're positive and you're frowning and you're upside down when you're negative. This is new. The width is determined by A. When A is equal to 1, then you will plot by squaring the x distance. You're squaring the x distance from the vertex to find your y distance, is what it is. That sounds confusing, but it's not really. So we're dealing with a graph that's x squared, right? We're squaring something. It's a quadratic. It's squared. So when A is equal to 1, because that's kind of like your slope, I like to refer to it as like your speed to the sky. So your basic graph, when you're dealing with just a regular quadratic, and you have a graph and it looks like this. If you speed it up, if you put a number out in front and it's a 2 or it's a 3, it says that you're going to get wherever you're going twice as fast, 3 times as fast. So you get skinnier. So instead of being like this, you get skinnier, you get stretched. If it's a fraction, if it's 1/2, that means you're going half as fast. So you get wider, you kind of spread out a little bit. So that's one thing to think about when you're dealing with A. And most of the time, I would say 3 out of 4 graphs that you make, A is equal to 1 or -1, then you'll be doing the same pattern over and over again. And because we're squaring, so you might want to jot down x squared because that's what it means. You're squaring whatever it is your x value. So when we make these graphs, they're symmetrical because whatever is on this side, it's the same on this side. They're the same. So really, we only have to plot the right side, and then you use symmetry to plot the left side, right? Yes? Yes. Okay, when we graph it, we will start with wherever our vertex point is, wherever your vertex is. From your vertex, if you move over a distance of 1, so you've got your vertex and you move over a distance of 1, what is 1 squared? What's 1 times 1? 1. So if you move over a distance of 1, you should just go up a distance of 1. Because that's 1 squared. If you move over a distance of 2, what's 2 squared? 4. If you move over a distance of 3, what's 3 squared? 9. And I'm not drawing this to scale. But if we moved over 4, how far up should we go? 16. So keep in mind that I am just assuming that we have a positive A. If it's negative, then it just means go over 1 and then down 1, over 2, down 4. So keep in mind that this is just for a positive graph. What that means is that if I come up to this graph, we're just going to graph the parent function. Parent function is y is equal to x squared. That's parent function for a quadratic. If y is equal to x squared, what would the vertex be? Not a trick question. Is there anything in parentheses? Is there anything after? So what do you think that the vertex would be? What is h and k? So what are h and k? What do you think? 0. Y'all are scaring me. That's the same thing as y is equal to parentheses x plus 0 squared plus 0, or it could be minus 0 in parentheses. Those are the same thing, right? Nod your head if you see that that's the same thing. Okay. So what would that vertex be? Zero, 0. Thank you. So the vertex would be 0, 0. And what is A? One. Okay, so that when A is 1, then we use this movement down here. That means we just go normal squaring. Okay, we're gonna go put a vertex over here at 0, 0. That's a vertex. And then it says that we're just gonna move in a normal x squaring movement. So I'm gonna go over 1 squared, or 1 times 1 is 1. So I put my point right there. I'm gonna go over 2. What's 2 times 2? So I go up 4. If I go over 3, what's 3 times 3? 9. So that's off the graph, but it would be, I don't know, like here. I'm going to use symmetry to draw the other side. I'm going to connect the dots. It's a curve, so don't make it like a V. It's a curve. So you want to have it kind of smoothed out at the vertex. It's not a V, it's a U. The domain, how far left and right is that graph going to go? If we look at this graph and we look at it as it keeps going, is it ever going to stop? No. What about this direction? No. So it goes forever both directions, right? Every time you tell me the domain for these quadratics that we're graphing, it will always be all real numbers. So again, that symbol, I know we've talked about it before. It's like 2 lines, and then you start the R at the first line, and it's just an R for all real numbers. The Y value, I believe, when you're doing these is easiest to represent with an inequality. So range goes with Y, and it's either going to be greater than or equal to or less than or equal to. Your graph's either above or it's below. So for this one, it looks like the lowest point I have is at 0, and the graph is above that. So I would say that all the Y values are bigger than or equal to 0. We're going to get a lot more practice with this. So let's start doing some examples. Our first example, we want to write, ultimately, we want to write an equation. So let's figure out these things. What is the vertex? Very good. -3, -2. What is the y-intercept? 7. So y is equal to 7, and we could also list that as a point. It would be 0,7. The axis of symmetry isn't present on the graph, but it's pretty easy to figure out. It's always an x equals equation. Where does it cut through the x-axis? -3, that is the equation. All right, to help you figure out what A is it facing up or facing down? Up, so it's going to be a positive number. And then A is always 1 if it moves. If it moves in this pattern, A is 1. That's what we said. When A is 1, it moves in this pattern. If it's not 1, it's some variation. It's you can usually figure it out by the very first movement. You either go over 1 and up 1, and it's just a 1, or if you went over 1 and up 2, then it's twice whatever that is. So it's usually A is 2. If you moved over 1 and you only went up a half, well, then A is a half. So you can always figure it out by that very first movement. So when we're looking here from our vertex, we go over 1 and up how much? 1. So what is A? 1. A is 1. The domain, what is it? All day, every day. All real numbers. For our range, what do you think it is? We know it goes with Y. Greater than or equal to -2. Very good. Very good. Very good. To write our equation, the only things we need to write an equation are the vertex, and we need to know what A is. That's it. We need a vertex and we need A. Remember that vertex form is y, it could be f of x, is equal to a, and then x minus h squared plus k. So for our equation, again, it doesn't matter if you write f of x or y, it's the same thing. My a value is 1. Do I have to write the 1 in front of parentheses? No, I don't have to. So x, and then my vertex has a negative h value. So what goes in parentheses? Plus. Okay, remember that anytime what's in parentheses is opposite. However, the k value, what you see is what you get. If it's -2, it is -2. If it's +2, it's +2. So the k value, what you see is what you get. So that is your equation. Yeah, I sure did. That's fun. There, thank you. The next graph, before we do anything, let's identify the domain and range. What is the domain? All day, every day. All real numbers. The range. We have to go count to find the highest. 5. So anytime that you have a positive graph, like the one, where is my mouse? When you have a positive graph, it's always going to be greater than. And when you have a negative graph, it'll always be less than, and you just find the vertex part. So this one's going to be the highest part it can go is 5. Here, the lowest you could go is -2. All right, what is the vertex? To 5, good job. What is the y-intercept? -3. So y is equal to -3, and we could also list it as a point as 0, -3. The reason I keep listing it as two different ways is you don't know how you're going to see it. It could be written either way. The axis of symmetry, it's going to cut through the middle of my graph. Yep. X is equal to 2. Now let's look at our A value. Is it opening up or opening down? Down. So automatically, if I'm opening down, I need to have a negative over here so I don't forget it in my equation. Now we need to figure out, is it going by 1 or is it going by something else? You're right. So this one, we go, normally if it's by 1, we would go over 1 and then down 1 and then over 2, down 4. But that's not how we're moving. We're going over 1 and down 2. And if we go over 2, normally we would go down 4. This one goes down 8. So that means that whatever it is that's being squared, we're doubling it. So it's 2. So you can usually figure it out by that very first movement. We didn't move by 1, we moved by 2. Again, that we only need 3 things to write our equation. We need we need vertex and we need A. So our equation, A is -2, so we got to put that out in front. My vertex is 2, 5, so it's going to be -2 in parentheses. And K is what you see is what you get. How are y'all doing so far? As good as we can, being at school on the Friday before break. Is that how we're doing? On to the back. So it's the same type of stuff, but now we're going to graph them. We're going to actually graph them. So for the equation that's given, what would the vertex be? 3, 4, right. Everything that's in that X grouping is always opposite, and K, what you see is what you get. So the vertex is 3, 4. Is that going to open up or open down? How do you know? Exactly right. So it will open down because in front of the parentheses, there's a negative. So it will open down. Anytime I open down, most of the time you open up, but anytime I open down, I give myself a little reminder when I graph it, it needs to go down. My Y distances. So what is the A value? It's -1. So I'm going to move in that regular X pattern or X squared pattern. So I'll go over 1 and then down 1, over 2 and then down 4, over 3 and then down 9. So I'm just giving myself a reminder of my X distances. So that's what my Y distances based on the X values. A lot of times, all you can ever plot is the first 2 points because usually you're off the graph by then, especially if it's ever stretched. So let's go plot this. My first point that I'm going to put on here is going to be my vertex point. So my vertex says that it's at 3, 4. This is why we make all those mystery pictures so that we are good at plotting points. So I went over to 3, 4. And now I'm going to plot using that pattern that I jotted down for myself, the Y, to figure out the Y distances. So I will go over 1, down 1, over 2, down 4. If I can, over 3, down 9. I'm going to plot those values. And I'm going to use symmetry to plot on the other side. As soon as I have my dots on there, I'm going to connect the dots and I'm going to try and make it as curvy as I can because it's not a V. That is my graph. What's my domain? All real numbers every single time. All real numbers every single time. For the range, I'm facing down. So what's my symbol going to be? Less than symbol. Okay, what's the highest that it goes? 4. That's how you do it. For question number 4, what is the vertex? Very close. So is there parentheses? Are there parentheses? No. So then what is in parentheses if there isn't even any parentheses? 0. So if you don't see parentheses, the X value is 0. The H value is 0. So 0, -7. How do you know it's facing up? Yeah, there aren't any parentheses, but it's still whatever's in front of the X value and it's positive. So we're going to open up. This one, A is not 1. What is A? A is 3. So if I'm looking at my X distances, normally I would go, let's see, we're facing up, so we're going to move up. So I would go over 1 and then up how many? 3. So I go up 3 and then I would go over 2. Normally I go up 4, but I wouldn't go up 4. I would go up 4 times 3. 12, 4 times 3. So 12. There's no way I'm going to be able to put 12 on there. I might be able to put 12 on there, but if I went over 3, I would normally go up 9. So I would go up how many? 27. That's not fitting on my graph, but I'll go ahead and jot it down anyways. So that would be my movements. All right, did you have a question? So I'm going to give you guys a minute. I want you to plot your graph and see if you can identify the domain and the range. So, did I do that? So you go over 1 and up 3, yes. Now when you go over 2, instead of going up 4, you're going to go up 12. So I didn't. No, because I don't think that 12 is right there. Because that's 7, 8, 9, 10, 11, 12 should be at 5. Oh, it should be at 7 and 5 is 12. Please check your graph and your domain and range. Check your graph and the domain and range. Anybody want to tell me what you messed up on? Did anybody mess up on anything? What'd you mess up on?
I started at the right vertex.
Okay, vertex point. You didn't plot the points right? Okay, so remember that normally we would go over 1, up 1, but these are saying we're stretching it by 3. So we're going to get to the sky faster. So we go over 1 and then instead of going by 1, we multiply by 3. So we go up 3. And then when we go over 2, instead of going up 4, it's 4 times 3. So we go up 12. So that's what this is right here that I'm doing.
From that. from the
Yes.
first-
So it's from wherever you start. So was that your mistake? Okay. Okay, so that's why I put distances. It's the X distance, or it's the Y distance from wherever you start at the vertex. So it's from wherever your vertex is, you just go over and then you start counting. So it doesn't mean that the value is 12. What about the range? Did everybody get the range correct? Even if you plotted the points wrong, you should have probably gotten the range correct.
So I shouldn't be able to play it 12, right?
Well, you can plot. No, that's not happening.
But I did do 2 and 12.
Good. All right, I'm hearing some really good talking out there. So I didn't shut y'all down because I heard some really good helping out there to help everybody understand that the 3 and the 12 and the 27, those are not actual values on the graph. It just tells you the distance or how many spots you count up from where you start. All the rest of the stuff that we're going to do on the worksheet is really simple stuff. So the rest should be really quick for us. Question 5 and 6 are the same. It says identify the transformations and write it in vertex form. So this is just applying things in, it's giving you function notation. But it's, you write the things in the space where it looks like it's going to be. So in vertex form looks like this. That is vertex form. Oops, I guess some of it's cut off, but it's squared up there. So you put the things basically in the same spot you see them. So what I see for the first one is that there is a 2 in front of some parentheses. It doesn't matter that there's the F there. That means there's going to be a 2 right here. A is 2. Here, there's a -3 in parentheses. It's still going to be a -3. There's a +1 at the end. There's a +1 at the end. Basically, all you're doing is removing the F and making sure that this piece is squared. But I do want us to also, it says identify the transformations. Let's talk about what they do. What is the 2 going to do to my graph? It's going to affect A. And if my graph is normally like this, what is a 2 going to do? It's going to stretch it, make it more narrow. It's going to stretch the graph. What's the -3 going to do? So remember, one way that you can remember is that whatever is in the X grouping moves in an X direction. X is left and right. So it's also opposite. So what do you think? -3, where do you think that moves me? To the right, because it's opposite. So we would normally think that negative would move me left, but it's opposite. So it moves me right 3. And then what does the 1 tell me? Up 1. So to write this in vertex form, there's a 2 in front of parentheses. And then a +1 at the end, a -3 inside. Because you could apply this transformation, you could apply it to a quadratic, you could apply it to an absolute value, you could apply it to anything. So to make it a quadratic, you've got to have the square out there. You could make it a cubic. A cubic would have a 3 out there, a exponent of 3. So don't let this form fool you. I mean, it's just telling you what kind of movements you do. For this next one, what do you think the negative tells you? Down, but more than that, usually we represent that transformation, we call it a reflection. So it's going to reflect. And more specifically, it's reflecting over X. So instead of facing up, you face down. So it reflects over X. And then what's the -4 tell me? Nope. Down. Because it's not in parentheses. So if we wrote this in vertex form, we put the negative outside and then we've got our parentheses. Nothing's inside the parentheses, so nothing goes inside. Looks like that. Any questions over these two on like what we're doing or where we get these pieces from? These are not trick questions. So if you feel like it's really complicated in your head, then please ask because that's a small disconnect. Are we okay with these? Again, these are not meant to be trick questions. Questions 7 and 8. Again, these are also not meant to be trick questions. We've got the regular format and we want to write left 3 and up 1. So I've got f of x is equal to, am I going to have anything in front of the parentheses? No, it would have to say it reflected or it was stretched in some way. What about inside the parentheses? What goes inside there? +3, because it goes opposite. So +3. What about after parentheses? +1. Very good. Good job, friends. Not trick questions. They're meant to be easy. Question number 8. I want you to try and write that one on your own. Mm-hmm. It would say reflected and it would say stretched. Mm-hmm. I probably am not going to have you do both of those.
Wait, so if it just says X is zero?
Do what?
If it just says X is zero? Or
This one says it's reflected over X. It's moving right 6.
I think that's what we do. I don't know which number that I put when it reflects, right? It has the X being reflected.
So look at question number 6. See how we said that that is a reflect over X and it ended up with a negative in front of the parentheses. Here it tells you that you reflect over X. So when you write your equation, there should be a negative in front of the parentheses.
Is it still gonna be 2 on the outside or do I like?
No,
how
it would
I
have to,
know?
it would have to say it's stretched. It doesn't say anything about being stretched.
I can just leave it like that and then add my 6 on this.
Yep. Okay, check your equation, see if you got it right. Yeah, sure would be. Check your work. How'd you do? Uh-huh. Uh-huh. The last question is an applications problem. But these word problems, again, are not meant to be a trick. So I am giving you a few minutes that I want you to try this one all by yourself. You can work together, but not with me. So I'm going to give you 4 minutes to answer these questions, to read the situation and answer the questions. Again, work with each other. In 4 minutes, we'll go over it together. So I would probably try and read it, answer the questions myself, and then talk to my people and see, did y'all get the same thing as me? When you get your answers, talk to your people, see if they got the same thing. Have most of you had time to answer that question? I feel like probably so. Y'all didn't need 4 minutes. Is that what you got? Is this what you guys got for your answers? It was pretty easy, right? The word problems for these are all pretty easy. So now you have 30 minutes to get started, maybe a little less than 30 minutes, get started on your assignment.